Dear viewers, welcome to another video on MINITAB tutorials. So this is a part 2 of the previous video where we discussed about probability plot. In the first part of the probability plot video, we understood how we use probability plot to understand whether the data follows a particular distribution. We saw an example for normal distribution. We also saw an example for variable distribution. In this video, we will understand how we can get more inference from the probability plot. So for this, I have taken an example of a company which make billiard balls. So this billiard balls that they have made, I have taken the elasticity of the ball as a data metric here. And here the ball is being made out of two different formulas. The material that is being used, we have categorized it as old formula and new formula. The first thing that we are going to see is whether the billiard ball that we have produced using old and new formula together, is the data going to follow normal distribution. So I click on graph, I go to probability plot, and in probability plot I select this data together, and I select elastic, and then I can select normal distribution as my distribution, right? And I can click OK. OK. So it gives me a graphical representation. And here the p-value is definitely greater than 0.05. In fact, it is very close to 1. So 0.978. So this data definitely follows normal distribution. So that's the first inference. However, I have to now compare whether my balls produced through my old formula and the balls produced through new formula individually, do they follow normal distribution? That's the second thing that I have to check. So what I can do is I can minimize this. I can click on graph. I can click on probability plot. And in probability plot, I can select multiple data sets. So here what happens? I select my elastic as my data. However, that same elastic had two factors. One is formula old one, another one is formula new. Right? Again, I can keep my distributions as normal, and I can click OK, and I can click OK. So now if you see here, you will find the distributions for both the data. That is, the blue color dots indicates new formula, the red color dot indicates old formula. So considering the different material used, still in both the cases, the p-value is greater than 0.05. So definitely the data follows normal. However, you can see there's a significant difference in the mean. There's a significant sorry, there's a significant difference in the mean of the data. If you see here, the mean of the data is somewhere around 75, whereas the mean of this data is somewhere around 54. So now what we are going to do is we are going to use the same probability distribution plot to get some more inference. So I press Control E to take it to the previous screen. And what I'm going to do is I'm going to use the percentile lines. So this is very interesting, percentile lines. And what I want to understand is, where do I have my 75th and 25th percentile? So what are the data points that fall within the 75th and 25th percentile? So that is something that I am going to understand. So what I'm going to do is I'm going to click on percentile, and I'm going to say 75 space 25, right? And then I'm going to click OK and OK. So what you will understand is, for both these graphs, where is the 75th percentile and where is the 25th percentile? So the 75th percentile data is somewhere around 48.85. Sorry, the 25th percentile of data is somewhere around 48.85, and 75th percentile of data is somewhere around 74.03. So this is for the old formula. Whereas in the new formula, the center 50 is somewhere around 70.47 to 81.33. So the data has a significant shift depending upon the formula that we use. The average or your center 50, the center 50 percentile of your data has a significant shift in terms of its elasticity. This is one inference. So let me minimize this graph. The other thing that we can do is, again, I press Control E. Maybe I would like to understand the same data in a different way. So I go to scale. I go to reference lines. So I'm saying, no, I don't want to know where is my center 50 lies, but I want to know what is the percentile value for 60 elasticity. Elasticity value which is 60. What is my percentile of data points which has elasticity less than 60 or greater than 60. If you want to understand elasticity less than 60, so I can enter 60 here and then I can say okay, and I can say okay. So now what will happen is you will have the same data but with a different understanding. So in the old formula 60, so where you have 60, 76.78 percentile of your data is less than 60 percentile. Whereas with the new data, if you see here, only 2.40 percentile of your data is less than 60. If your target is to produce balls with elasticity of greater than 60, then actually your new formula, new material is better suited because it gives a much better yield, right, compared to your old material. So these are all different ways by which we can use the same probability plot to get more inference out of data. So I hope this video was useful. So I will give you the link for the part 1 of probability video in this video description. So if you missed to watch the part 1 of probability plot video, you can get the link from this particular video's description. So both these videos together will give you a fair understanding of how you can use probability plot as a graphical representation to get more inference about your data. It gives you inference about the distribution. It gives you inference about the goodness of fit to the expected, estimate values like mean and standard deviation. It also gives you a percentile view of your data points. It also gives you a concentration of data point between two different percentiles. These are different things that you can understand using probability plot. Thanks, friends. Thanks for watching this video. See you in another video about MINITAB tutorials, whether we can see about a statistical tool or graphical representation. Thank you.